Welcome back to Eugene. You got it now. In this video, we will talk about rejection region and we will be guided by two objectives. First, to identify the rejection and non-rejection regions and the critical values. The second objective is to decide if the null hypothesis will be rejected or not. Let us discuss related terms related to rejection region. The first one, of course, is the rejection region, also known as the critical region, and it refers to the set of all values of the test statistic that causes us to reject the null hypothesis. The second term is the non-rejection region or acceptance region. It refers to the set of all values of the test statistic that causes us to fail to reject the null hypothesis. And the third is the critical value, which is also known as the boundary on the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. These three terms will be illustrated as we move along. We have here an illustration of a two-tailed test. Let us recall that we will have this kind of illustration if our alternative hypothesis uses the symbol of not equal to. Based on our illustration, there are two shaded regions on both ends of the graph, and we will call it the rejection region. And at the center of the graph, which is the color Y, that is the non-rejection region. Another illustration here, let us call this as the one-tailed test. But to be specific, this is a left-tailed illustration. We will use this one if our alternative hypothesis contains the symbol of less than. For this illustration, the white area or the non-shaded area is the non-rejection region, and the shaded region, the gray area, is the rejection region. Another illustration, this is still a one-tailed test, but to be specific, this is a right-tailed test. We use this one when the alternative hypothesis contains the symbol greater than. And the white area is the non-rejection region, and the shaded area is still the rejection region. So we will use the left-tailed test if the symbol contains less than, and it is a right-tailed test when the alternative hypothesis contains the symbol of greater than. These are the steps in making a decision if we are going to reject the null hypothesis. Step number one, we have to locate the critical region, or this is the boundary. Step number two, we are going to shade the rejection region. Step number three, we will locate the computed value. And for this one, we will use broken lines. And step number four, we are going to make a decision. This will be our guide for making decisions. If the computed value is on the rejection region, our decision is to reject null hypothesis. If ever the computed value is on the non-rejection region, our decision is we fail to reject the null hypothesis. Let us answer and analyze example number one. What is our decision if the critical value is 1.833 and the computed value is 1.593? So These are the steps again. The first is to locate the critical value. Our critical value is a positive number, 1.833. So looking at our graph, the positive numbers are on the right and the negative numbers is on the left. So our critical value is on the right. This is the location of our critical value. It passes 1.5, or it is in between 1.5 and 2. That is the approximate location of our critical value. Step number 2, we have to shade the rejection region. So this is a one-tailed test, and this is our rejection region. So the shaded area is our rejection region, and the non-shaded area is the non-rejection region. Step number 3, we have to locate the computed value. Based on our given problem, the computed value is 1.593, and that is found in this area. Now, approximately the computed value passes 1.5, and it did not reach our critical value and rejection region, and we are now ready to make our decision. So, our conclusion, since the computed value is on the non-rejection region, therefore, we failed to reject the null hypothesis. Example number 2. A medical trial is conducted to test whether a certain drug reduces cholesterol level or not. Upon trial, the critical value is negative 2.25, while the computed z-value lies in negative 2.715. So our critical value is a negative number, and our computed z-value is also a negative number. So based on the illustration, it is on the left side. I mean, the negative values, the negative numbers is on the left side. So let's answer this one. So step number 1, we have to locate the critical value, and that is negative 2.25, and that is in between negative 2 and negative 2.5. And step number 2, we have to shade the rejection region, and that is our rejection region, and the rest of the graph is the non-rejection region. Step number 3, we have to locate the computed value. Based on the problem, the computed z-value is negative 2.715, and I believe it is in this area. It lies in the rejection region, and we are now ready to make our decision. Since the computed value is on the rejection region, therefore, we will reject the null hypothesis. Example number 3, sketch the rejection region and the test hypothesis with the critical values of positive, negative 1.753, and determine if the computed t-value of negative 1.52 lies in that region. So notice that our critical values are positive and negative. This means this is a two-tailed test, so there are two rejection regions on both ends. So step number 1 is we have to locate the critical value. So we have to locate the positive side on the right. So that is the approximate location. of the positive 1.753, and on the left side, we have the approximate location of the negative 1.753. And our step number two, we have to shade the rejection region. And these are the rejection regions, the shaded area on the both ends of our graph. And at the center is our non-rejection region. Step number three is we have to locate the computed value. Based on the problem, the t-value is on negative 1.52. So that is on the left side. And this is the approximate location of our computed value, negative 1.52. It is very clear on the illustration. So this is our conclusion. Since the computed value is on the non-rejection region, therefore, we fail to reject the null hypothesis. Thank you so much for watching, Eugene. You got it now.